Hi folks, welcome to my Bit Retro Journal. Today I want to do a little bit more in-depth look of operating systems in the 80s. I did a 4-part series where I looked at multitasking. What I wanted to look at this time is disk caching, because this came up recently for me on the QL because I was trying to recover some bad files off of the microdrives. As you can see, my QL is set up old school, so I took my my card reader, my microdrive card reader off, not using it right now, and just using an actual microdrive to demonstrate a cool thing that the QL does, which is something that a modern operating system does, which is file caching. And so the QL does dynamic file caching, meaning that when it reads in data from a disk, it actually creates a arbitrarily large cache as needed to read the data, and all the way up to the amount of memory it has, which is kind of unusual. It's sort of what modern operating systems do, and I'll show you what Windows does. You know, some of the other ones I've looked at, other machines I've looked at in the 80s, the Amiga and the Macintosh, both do static file caching, and I want to demo that to you as well. In fact, a friend of the channel, Dave from Dr. Dave's Diversion, that's another YouTube channel that you should watch, and I have a link in my description below. He does Amiga and Commodore stuff and some Mac stuff. He actually tested this out on his Amiga 2000 using Workbench 1.2 to demonstrate this, so I actually have a real hardware test. And then I'll also talk a little bit about the Mac. I couldn't really demonstrate this on the Mac because I'm using the two emulators that I'm using aren't necessarily well suited for that. There's lots of seemingly other caching going on, because I can literally copy a 500K file multiple times and it doesn't ever hit any disk, and it's instantaneous. So something is going on there. So those are the three machines I'm going to look at. Now I know there's other operating systems out there. There's, for instance, the Atari ST. It's a single tasking operating system, although it's still a powerful machine. And I did look at it. It doesn't look like it does any caching. I used Steam, the emulator. It seems like it hits the disk every time. At least it shows you that it's hitting the disk every time. It has a display where it says hitting drive 1 or A or B. Yeah, I just don't know the ST well enough for me to try to do a specific video on that. You know, I try to pick the machines that I kind of like, and not to disparage the Atari. In fact, it's one of the sets of 4 computers in the mid 80s that all sort of changed architecture to this 32-bit Motorola 68000 architecture. Even though the QL uses an 8-bit data bus, it uses that 32-bit architecture. This is also part of the Amiga series, so hashtag AMAYGA, celebrating things Amiga in May. So I will say the Amiga 1000 was my first computer in college. My roommate or suite mate had one, and the 4 of us all used it constantly, played games and stuff on it. So that was my first experience past the ZX81, and then the Mac 128 and 512. So the QL was actually last in the series, only because that's what I bought when I was out of school, and that's all I could afford. I got it for $99. And then I went the Mac route instead of going the Amiga route, because the Amiga was, I think, starting to struggle in the mid-90s. In any case, so that's what we're going to do today. So let's start with the QL. So on the QL, you can see that I have MDV loaded. It's got mostly full, and this is the ZX simulator. And I know you can't see below the screen where I'm going, but I know through my booklet that there is an info page one where you can get the info. So length is 48K for the ZX simulator. Now, I'm not going to do that for the ZX simulator because listing 48K with a microdrive can take forever. But I did it off screen. And when you copy... So, by the way, the trick that we used on the QL is if we're trying to recover a file from a bad MDV, we would actually copy that file to the console, and it would maybe take a long time. Sometimes, you know, this takes 7 seconds to go through the whole tape. Sometimes it would hit each sector, and you'd go, hit the sector, and list it. But sometimes it would take 7 seconds all the way around. and then you'd get the next sector. And if it was a bad one, it might take a couple of spins around. But if it hit it and listed to the screen, you were golden, because if you got everything listed to the screen, you could then copy that bit of that file to another microdrive, and you knew it was cached. So it literally would hit the microdrive just for a second, just to make sure it was still the same microdrive. So the QL doesn't capture its drives like the Amiga and the Mac do, meaning that it doesn't know the microdrive is there unless it checks for it each time. So it'll whir the disk once, but then after that, it'll just list it. So when I listed ZX, the ZX simulator at 48K, it took a long time to go through it. The second time I listed it, it just went, nice and slow, but continuous, and never hit the drive. In fact, you can take the drive out. I will show that instead with this file, because it's about 13K in size. That's my game Battleship. So I'll list that. Oops. And that one I think is like 12,900 bytes or something like that. And yep, 1292. And so I'll do a listing to that to screen, so you can see that the first time you list, the second time. And then to just show you this also works in programs, I will, in my Elite game is 7K. And the reason it has to be smaller is once I have ZX Simulator running, which is going to load that, it's going to do its own memory management. So I have to have enough memory left over to I can actually do these things. And so that's only 7.5K in size, or 7K in size. And you can see how much memory. So the QL has 128K. 32 is used for screen, and it leaves you 96, but you lose a few more for other stuff. ICE takes up a little bit too, so I think I have 75 at the moment, but usually between 75 and 77. But when I quit ICE, I think I'll get a little bit more from that. And I also run Baton Twirler just to demonstrate one thing that the QL doesn't do, which supposedly the Amiga and again, I don't know about the Mac. The Amiga claims that its static buffer size, so that Baton is only 7K in size. Its static buffer size on the Amiga is supposed to be for running programs, loading programs. So if you load them a second time, or if they're hitting the disk constantly, then you save that time. Well, you'll see in Dave's video that he couldn't demo that because it would hit the disk every time anyway. So we don't know what was going on there. But the QL doesn't do that. So let me get out of this interface here. Yeah, there we go. So if I run, so I'll do the Baton one first because I'll have to reboot the QL. If I execute mdv to Baton exe, you will see that it's going to hit the disk. So you can see the light, you can hear it whir. And it loaded it. Now, if I was just kind of rubbing on something here. Oops. If I load it again, it will actually hit the disk again. So it is not caching programs. I don't know why. I don't know if each program has to add some data space, if that is clashing with the cache space, but you'll see. And it's not just hitting, like if it just hits for a second, it means it would hit the front of the top of the drive, just make sure it's the same drive. But it's actually, it seems like it's loading it in. It might be slightly less, but I mean, for long programs, it seems to be reading it in for a pretty long time. So, and again, I'll run it a third time. I'm not going to run these, and unfortunately, I can't quit them because I don't have Toolkit 2 on here. But again, oh, it didn't find it. For a second, I thought, oh, it worked. Yeah, see, it's taken just as much time. Yeah, so it's, you're not saving anything. And now, of course, I have 3 of these programs running. I don't know what that one is. I think that's one of the Baton Twirlers. That's the other one. Oh, I must have given the wrong expression. So now you have 2 running. I think, yeah, I must have given, I must have given a character or something by accident. But anyway, so those are the Baton Twirlers. So what I'll have to do is I'll just have to reboot. Just hit the old. If I keep the Alt key down, actually it'll avoid ICE for me. So trick I learned. So we can go right back in. So now I have about 80 some K left. But what I want to do is, first of all, I'll show you directory listing. So if I do directory listing from scratch, it's going to hit that disk. And you can see that the whole thing kind of runs as it's reading. If you hit it a second time, and this actually works for a long disk, you'll see that the second time. Let me do this again, because I think it's an easier thing if I let me reboot just to clear out any cache. I think the thing to do is to if I do a directory listing into stream 4, into stream 0, sorry, it'll list it. So Windows 0 is where my cursor is. So if I do a dir 0 mdv2, you'll see it's going to do it here already. Here we go. Oops, I think I need to have a comma there. Let's see if this is a little faster now. Number 0 mdv2. It does again. If it's unfortunately I don't have a lot of small files to put on, but if it's a pretty long file, what you see is or if it has to go out and hit that disk a second time because it can't find the sector, it usually it usually just lists the rest of the record. This is just too short of listing, but I have you know, if I had 20 files or 40 files in there, initially it would hit the disk for that second part, but here, because it's all in one block, it's hard to show that. But it does cache directory listings as well. But so let's do the big test. So I'm going to run, and I might fast forward over this because it's going to take a while to read the ZX simulator. So here we go. Oh, MDV2, not 4. I'm so used to running it off of. So this is going to take a while. So I'll probably fast forward over this. Okay, it wasn't actually that bad. So if I load my Elite program, you'll hear it's going to look for it, and that might take 7 seconds. And then once it's found it, you'll see that the disk is going to stop, and then it's going to go and kind of go in pulses. Hopefully it'll find it. But at one point it's going to go into pulses where it goes zzz, zzz, or maybe it won't, depending on how it's laid out on the disk. But yeah, so now you see it stop, and now it's here. So it's found it. So the first part is just, is it still on this disk? And then it just goes, yeah. And eventually it's going to have it in memory. So here it missed the sector, I think, and had to go back to the start and grab it. And again, this was life with microdrives. It's just, they weren't super fast always, but I think we have it now. So if I run it, right, it doesn't actually allocate much space in memory. So so here it's running, and I can actually quit this and then load it again. And you'll see this time, it will have cached it. And I'll give you a better example of this here in a second. In fact, I'll leave this program running just to show you that with limited memory, this should actually work. I think I have enough memory to run Elite and list the Battleship program, which is 12K. So here we have a 48K program that's probably taking, and now you see it stopped and it's loading it in. So here's where you would have gotten the pulsed, but it's not pulsing because it has it in cache, and it's literally it loaded into memory. So that's the dynamic cache, and it's, you know, so yeah, so now this will still run. And if I go and say copy MDV2 Elite BAS to console, it just tries to find it the first time, and then it's cached after that. Before it would have pulsed. I'm going to try to see if, having maxed out the memory, I'm going to try to list the Battleship program, which is almost twice as long as this one, and we'll see if I have enough memory for it to be cached fully, or how does it interact when memory is being used by another program. And so, in fact, we could probably even multitask these if we wanted to have, yeah, maybe we'll do 3 times that. So if I do, so notice it never hit the disk. Copy MDV2 Battleship BAS to con, and you'll see that it has to find it on disk. Now it's listing it, and it'll just do this pulsed. And this is actually the best feeling in the microdrive when it hits every sector sequentially, and I think it's going to skip one at one point. Yeah, so it's really nice, and you can see that, but you can see it's hitting that disk. But the second time, and I'm not quite at the end yet, but once I get to the end, you'll see that if I relist it, it will. If it had enough memory and cache to do it, it shouldn't hit it. So it'll depend on how much memory I have. But again, I have about 80 or so available. ZX Simulator is 48 plus however much its data space is. And then of course it allocates in the heap, and the 70K program probably took about 7 or 8K, so it's probably taking about 60 or so K. So I still should have 20 or 30. And here we are. So if I copy it again, let's see what happens this time. Hits it, and nothing. So it's cached, and the ZX Simulator is still running. And in fact, I'm going to do it one more time, and I'm actually having the game play while I do it. The screen will be all messy, but that's okay. Just wanted to show you that, yeah, so this is literally a, and again, if I was trying to list the ZX Simulator, which is 48K, with not enough memory, the cache wouldn't work. I don't know what it would do if it would only cache part of it. I'd assume it would cache part of it. So but right now, it's using the maximum amount of memory the QL has available. It has 20K left because ZX Simulator is using 60 of it, or 25K left, or ZX Simulator is using 65K. Plenty to list a 12K program, and so there's no. But you don't lose memory because you have to set it aside statically. This is what the Mac and the Amiga do. So this is why this dynamic stuff's pretty cool. Oops, sorry, I want to actually go. Let me go in here. Let me run this. And we're going to just let it run. So the way we're going to do this is we're going to say start. And so that's just going to start. So now it's kind of playing the game. So if I go back, I can once again MDV2. Again, unfortunately, unlike the Amiga, the QL's windowing system does not. But the game is playing, so you can see. And if I list it, the game is still playing, and you'll probably see the at one point it's going to update the screen. What happens if I hit fire? Yeah, so you can see that you saw a block go because it was updated. So it's running. So it's doing the trying to get it to fire. But you can see those little blocks that you see are literally the game playing. It's just being tasked out a lot by and I don't have Toolkit 2 running on this right now, so that I can really up the priority on that. So it actually lost some of the cache. Second time around. Yeah, so maybe playing the game, I used some memory up. So I was trying to fire. Yeah, so there you fire. So go back. Let's do it one more time. It's just curious, and then we'll call it quits. Does it reclaim the cache when it loses part of it? There you go. So for the most part, it's not hitting it. This time I'm not going to do any key input. I just let the game play as is. So the ZX Simulator obviously does have to take some memory aside, little bits of it. And so if it does, it could eat into the cache. But let's see if the second time when it had to hit the disk, it refilled the cache, and now it sort of lives in harmony with the program. Let's see how smart the disk cache system on the QL actually is. But so far, again, it's pretty impressive. 48K operating system in ROM, and 128K system with 32K for screen, so it really has less than 96K available because there's other system variables and whatnot. So probably about 85K available for program stuff, and the ZX simulator is about 50K of that, and plus its memory, and this 12K. So this isn't really working. Yeah, so this time didn't hit the disk again because I didn't do any interaction, and you can see it's still running. So anyway, that's dynamic disk caching on the QL. Doesn't unfortunately do it for running a program. So I don't understand why, so I'll dig into that, but it definitely does it for data transfer, like copying files or loading files, etc. I'm not talking about write caching right now, so just reading, because it's, you know, with an old these old tape drives, it's actually important that you do make reading more efficient. And so they did this not because they were like, oh, we're going to be super smart and have the best operating system. They did it out of necessity, right? It's that old saying of necessity is the mother of invention. These drives are so slow that they had to go and say, we need to speed this up somehow. So, hey, let's create a fancy disk cache, dynamic disk cache system on a microkernel in 1983, 84 on a small amount of memory. So that's pretty cool. So next we're going to go on to the Windows machine, show you how Windows does it nowadays, which is even cooler. And then we'll have Dave show you the Amiga. So I have on this computer a couple of things. I've got a floppy disk inserted. Maybe you can hear it on a USB drive. And that is, you can hear it sort of, so the Windows is capturing that disk right now. So that's what this is right here. I've got this resource monitor open, which is a pretty cool, it's much better than Task Manager. And it kind of tells you how much memory is in use. And you can see how this grows. Now, with doing this test on a floppy drive is somewhat useless. If I go under games, first of all, if I do directory listing, it lists it, and then the second time it lists it. But and it's hard to see anything in this area for that. But you can see, though, the immediate nature of, so it definitely caches it, but how it caches it, I mean, I suppose we might glean that this is going up a tiny bit, but if you go to Chopper, so I didn't see standby change at all. I guess I should look at cache, but I wanted to, if you just sort of type, I think you say type mission s dot pass, and so let's keep an eye out on this memory, see what happens. So it's already changed. Here we go. Yeah, oh, it went up to 90, 91, 92, and okay, so it stays at 92, and if I do it again, it doesn't go up again. So yeah, so maybe this is showing you that it's dynamic, but it's actually going up anyway. So it's hard to tell on this stuff because there's other things going on. So it's going up to 90, so it's actually growing. So I don't know if that has any, certainly, there's not a direct response to, yeah, so this is still growing. So like I said, it's not, and you look at standby. So it's hard to tell whether that has an impact or not. Let me do one more. Type Chopper 2 pass, which is kind of a big one. This time let's take a look at standby. So that just grew. Oops. They're still all growing. 03, 04, so it's going up. So they're both going up a bit. Yeah, but I guess it's going to be hard to say that, because even if you don't do anything, it's going up. So it's 2707, it's staying stable. It's back to 8. So this is slowly growing. So something else is obviously caching this, staying at 8. Now it's 9. Yeah, so it's hard to tell because that's a pretty big chunk. So there's no way to know this. So a better test for this is to use this. So here on this, I have right. I have the Office 7 Enterprise Edition no key, which interestingly enough, I actually own this Office 7 edition, but I found the ISO image. So I'm not suggesting you should go and find free version, but yeah, I couldn't get the key to work. I actually got the key to transfer over, but it was a big pain. I had to call Microsoft. Anyway, this is a pretty large disk. So now if I copy this onto my desktop, watch this. You can just watch the blue chunk because it kind of mimics that. If I paste this, it's going to basically add 500. And you can see it takes a while to do it. And yeah, it takes a good amount of time. So it's a good test. Now, if I do it again, you'd think that nothing should change here, but it actually does. And it's interesting. So I'm going to change this to 1. That shouldn't impact anything. Right? So this is caught up. So now if I do it again, you'll see that it actually grows again, just as much as it did last time. So I think what's going on here is that it's not only caching this file here, but it's actually also caching these copied files, so that if I want to use them, it already has them in memory. So it's not only caching the read, but also what's been written, so that these are both now cached, so that if I want to copy this somewhere, it doesn't interfere, that it doesn't have to reread something they just wrote. So I think that's what's going on. Now, if I actually paste this here and overwrite it, will this go up? And it does not. So that makes sense. So here, it actually replaced the file. You saw it shrink and grow again. So that keeps its cache. That has cache now, and this has cache. So basically, all 3 of these now have cache values so that you can use them. So that's pretty cool. I think that's what's going on. I'm not an expert on Windows 7. If you know better, please comment in the link below. What I want to do next is let's go check out Dave at Dr. Dave's Diversion on the Amiga, and he'll show you how he's done it there.
So here I have the original Workbench 2.04, the disk. I don't want to use my modified customized disks because sometimes I change the add buffers command. So let's boot my Amiga on the 68000 with that original disk for 2.04 to sort of understand where that add buffers feature went, and then I'll do the same thing under 1.3. This also takes my hard drive installation out of the picture, and what it means is I'll be booting off, let's label the drives. DF0 is shown in the video on the right. That's where I'm going to be running the operating system from. And if you look, it's Amiga Release 2, Workbench 37.67 here. So we're going to be running the operating system off DF0, and then we'll use DF1 for some of the tests that you wanted to run. All right, so this is the floppy disk that we booted from. Let's start a shell there. Okay, so the first thing to remember is, since we booted off DF0, it's going to be accessing commands there. So if I say, for instance, let's say like the date command, you see that it reads it from DF0. So some of the activity on DF0 is going to be it reading operating system components. If I run add buffers, of course in 2.0 it's nice because it will tell us, or it can tell us what we're currently set to. So DF0 by default here has 20 buffers, and if we say add buffers DF1, it only has 5. I don't think that there's a way to remove buffers. I'd have to change the startup sequence on the disk to do that. This is the way they shipped it. So we can only add buffers, and it adds it to what's already there. So your experiment, you wanted to do an experiment with 32 buffers, we'll have to do the math and figure that out. Just as an aside, even though I booted off of the floppy here, if I look at how many buffers are on the hard drive, it has 30. So there's some intelligence going on, like it's saying you should have more buffers on a hard disk than on a floppy. Okay, so let's do the experiments now with DF1. So DF1 has 5 buffers, and if we say dir DF1, you can see it's accessing the disk and it reads it there. If we say dir DF1 again, now we expect it to hit DF0 to read the dir command. and then hit df1 just to read the directory, and we see that again. Now you said the experiment you wanted was with 32, so if it's got 5 buffers now, we'll add buffers df1 27. Okay, so now we've got 32 buffers on df1, and if we dir df1, we hit df0 to read the dir command, we hit df1 to read the directory, and now let's do it again. Okay, there it didn't have to hit the disk again. So the original 5 buffers was not enough to cache, apparently, the directory for df1, but when we upped it to 32, it is. And now I put a file on df1 there. You can see they're called 10,000b.txt. That's the 10,000 byte file you asked for. So let's say to type out df1 10,000b.txt. So here we expect it to read the type command off df0 and then start reading the file off df1. And in this file, I've numbered the lines. Each one is an 80 character line, including the new line at the end, and there's 125 lines. So 125 times 80, it gets us our 10,000 bytes. And through that, you can see it pauses occasionally. So it's probably at the system call level that it's reading in chunks, and that's what it did. Now, if I say to type that out again, there it's hitting the disk again. There it hits the disk again. So it looks like it takes three system reads or something of the disk to get that. And you can do that over and over. It has the same behavior each time. So let's try something extreme. We've got 32 buffers there now. Let's jack that up. So let's say something like add buffers df1. I don't know. Let's add 64 more. Okay, now we have 96 buffers there. We do dir df1. It doesn't have to hit the disk because that's already cached. And if we type 10,000 b.txt, hits the disk again there. Hits the disk again there. And then we're done. So that was the same. Now let's see if it cached any more of it. I don't expect it to have, but let's see. Okay. So there was no difference in reading the data from file when we upped the number of buffers to 96. And that definitely, raising it to 32 from 5 definitely changed the caching of the directory structure itself. All right. So now what we can do is take out the release 2 disk and let's switch to the 1.3 disk. So this is Amiga Workbench version 1.3, and the specific release numbers there. We'll see it again when we're booting. And 3-finger salute. Okay, so here we can say, I think it's going to fail, but I'm going to try to examine the number of buffers. Okay, so we're going to have to guess how many buffers there are or something. But so let's try. So before we had 5 on df1. Let's just make the assumption that there was 5 on df1, and we'll say dir df1. So it hits df0 to get the command, and then it gets the disk. Dir df1 reads the command, reads the disk. Okay, so however many buffers there are on df1 right now, it's not enough to cache the directory. So we type df1 colon 10,000 b.txt. Looks like it results in 3 read operations to the disk. Do it again. All right, so now we add buffers. df1:27. So it's no longer hitting the disk when we're doing a directory with this number of buffers. And if we type the file, 1 read, 2 reads, 3 reads from the disk. One more time. 1, 2, 3. Now this might be caching the type command now, because I saw the df0 flickers just for a split second. Watch it. It's the shortest access ever. What if we run another command, like say the date command? I don't think we're seeing any evidence of the executables being cached. All right, well, that's what I have.
So thank you, Dave, for taking a look for me with regard to Workbench and disk caching. The add buffer command, by the way, specifically states here that this command assigns a large buffer to a specified disk drive. When working with Amiga DOS, sometimes a command can be loaded from the drive before it is used for the first time, and then the command remains in memory for subsequent command calls. The reason for this is to find the disk is found in the disk drive buffer memory. The operating system loads all data into the disk drive buffer before it can be used elsewhere. If a program is small enough, fit in the buffer, it doesn't need to be recalled from the disk or hard disk again. The speed up execution. Now, at one point, he created a large buffer because when you do a buffer, each block is 512 bytes. So if you do 100, that's 50K, and I don't think the date command should be more than that. So yeah, it was a little confusing, and it also states here that version 1 and 2 are identical, and it didn't have it in Workbench 0 and 1, as far as I could tell. But it did have it in Workbench 1.2 and upwards. So yeah, if you have any more information about disk caching in the Workbench 1.0 through 1.3, why we didn't quite get it to work and why it was constantly hitting the disk. Also, it seems like for files it did not work. So moving on to the Macintosh, I didn't have much luck with the Macintosh. I have both Mini VMac and Basilic running. They both have 512K ROM 2 kernel, ROM Mac 2 kernel, and they both are running the same Macintosh. The screen is just a little bigger there about this Macintosh. So the problem is, first of all, Mini VMac can access disk images, but not disk drives, whereas this Basilisk can. I've got a drive in here. You can hear it. I'm going to check for floppies, and it'll actually load. While it's doing that, I guess it's slow. I'll go here. Both of them are set up the same way. Memory is cache is 32K, and it's always on. The one difference on this one is it actually shows you more. So maybe because this is 24-bit addressing, this is 32-bit. I tried to turn this off because this disk actually has System 607 on there, but I could not get it to boot. So it has this additional feature, but 32K of RAM. But what I've discovered here is if I copy, so this file, so I have something to copy to. This file right here, if you look at it, is It is 400K or so, 500K, so it's half a megabyte or so. Again, it's taking its own sweet time because it's, yeah, so it's 400K in size. If I copy this over here, just by dragging, it's going to hit the disk sector by sector and copy it, given whatever speed my USB floppy drive is. It's not horribly slow. It's what you would expect. But you would expect, because the disk cache is only 30K for a 422K or 412K file, that if I toss this in the trash and do it again, it shouldn't be instantaneous. And so there's, you know, I tried all these smaller ones, figuring that this would cache and this would and this wouldn't, but I mean, it seems like it's already caching here. And the same goes here. If I have these different sizes. If I make a copy of this one, okay, and if I copy it again, and I'll throw this in the trash, it's really hard to, it's really hard to see that it's running any faster. It's just kind of taking the same speed. Like, it's not instantaneous. And then for the 290, and of course, if I use a 49K one, it takes the same speed, and in fact, yeah, I mean, they all take the same speed. These emulators must do some caching. Maybe the USB disk drive through Windows is doing some caching. So one thing I did find is this document by, this is a long bunch of lists of technical, I think I just named this Mac cache. I think it has a bunch of 974 pages of technical documents. And page 797 has a technical note by Rick Blair that talks about the technical note describes disk and file system caching on the Macintosh with a particular emphasis on high level of file system cache. Of the 3 caches used for file I/O, this is the one which could have the most impact on your program. I'm assuming the other caches are low level at the disk level that are small amounts of cache to make things go faster, whereas this one is like the disk, I guess I should call it a file cache or drive that the QL and the Amiga tries to use with add buffers, and the QL just does it dynamically. And so here it says, in this note, it will use a term, hardcore file system and Sony drive, which can access the 100K drives. Both RAM-based HFS and the 120 ROM version include the 2nd generation Sony drivers. All right, so this is not available in 64K ROMs, and it states here. So it's pretty detailed, which I like. It talks about how it's implemented. I'm not going to go through the whole thing. I go ahead and take a screen picture if you want to read all this stuff. And if I missed something, I thought I've been through this pretty well. Cache track fever, cache me if you can. It's kind of interesting how they've written them. Right, so it's only available on 128K or greater RAM. And at one point, he actually talks about the caching code always makes sure there's room for 120K of application heap and 30K of cache. If the user requests the amount would reduce heap cache below these, it's readjusted accordingly. So obviously, this isn't going to, well, this isn't going to work for 120K Mac because it was not at 128K ROM. And so not in 84, this probably started coming to use in 85 or especially 86 when this technical note was being made. Up to 36 separate files may be buffered by the cache. Each queue is a list of blocks cached for that file. Information is kept about the age of each block. It's not kept in list of order and they occur. Talks about the aging of it. So it's pretty nicely technical detail, which is kind of cool. He also talks about write caching, which again, I didn't cover that on the QL in terms of purging a file out. But so anyway, the Mac, yeah, I don't, other than this technical note, it definitely does static disk caching, but I couldn't test it for you. But in any case, so those are the 3 of my favorite systems, the original 68K Macs. If somebody has one, if you could test, sort of repeat Dave's test with the Amiga. Again, the Amiga is one that I'm seriously looking to try to find an Amiga 600 NTSC version. And so, yeah, that's all I'm going to cover for today. Thanks for joining me. I definitely will appreciate comments on this video because I wasn't able to solve everything or demonstrate everything clearly. But if you have some more knowledge on both the Amiga and why it wasn't quite doing what we expected, and what the earlier models of the Mac in the 80s running System 6, how caching worked there. If you have an all floppy, that would be great. Just to compare it to, again, the QL with 128K of memory and those god awful, right? Actually, I like the microdrives, but a lot of people will call them god awful microdrives. Necessity, right? Had they not done that, it would have been a worse experience. So pretty cool to have to add advanced operating system features on a computer that's lacking otherwise in hardware. So I think that's kind of funny. Thanks for joining me today, and I will see you soon.